Welcome to another episode of The Graph Show. I have with me today Tomás Sabat, COO of Vaticle, creators of TypeDB and TypeQL. It's a database that I've been interested in for a long time. About 5 years is when I first heard about it. It was called Graken at that time. And I was really intrigued by the way that Graken approached hypergraph databases sort of by way of relational schemas. So elements in the graph were basically rows in a relation, and could link to other elements in the graph by means of what I think were called roles at the time. I think they're still called roles, but basically, cells in a database row, and that seemed really powerful. I think you had a Haskell client, which told me you were kind of serious about type systems. And then at some point, I stopped hearing about Graken, and I don't know when exactly that was, but I was kind of disappointed because it seemed so promising. And then I found out that you had rebranded to TypeDB, and this TypeDB thing that I've been hearing about from many different angles was actually Graken. So I was interested in asking you about the current state of TypeDB, and also, since this is a graph show, that journey from hypergraph database to what TypeDB is today. Definitely, I'd like to talk a little bit about types and queries and kind of the formal foundations of representation and queries and reasoning in TypeDB. So if you want to
awesome.
Those,
let's
start with the history, if you don't mind.
Oh, sure. And firstly, thank you, Josh, for having us today on the Graph Show, and thank you, Lynn, also for producing in the background. I think so. We started the company 6-7 years ago already, and largely our challenge, which is sort of the guiding, which is something that we've always worked hard on throughout our journey, is that we're doing something very different to all of our friends out there in not just the graph space, but the database space. So when we started the company, the first open source release was made at the end of 2016. We built this new language that at the time was called Grackle. We thought, you know what, we're crazy, let's put it out there as open source. And soon we started organically to get users using the software for different things. And I think later at the beginning of 2017, we had someone present in Texas about decompiled the source code of one of the Apollo moon landers and then used the rule engine to represent some commonly known bugs from DARPA to build sort of pseudo source code verification system. But all of it telling us that actually our approach, clearly there's benefit in ways that we couldn't even anticipate from the get-go. And and then in 2017 we were awarded Product of the Year by the University of Cambridge. We're based in London, by the way. I'm calling also from our offices here in London. This is our office, by the way. This is not a Zoom background. I'm actually in the office. And then 17, 18, very much heavy focus on R&D. As we move into 2018, 19, productizing the product while also growing the community, doing a lot of evangelization, growing our own community, especially the life sciences, a lot. And then pandemic hit, and one of the realizations that we had, because we did our first user conference at the beginning of 2020, and you won't believe when we did it, literally 6 weeks before lockdown, I think, in February, second week of February of 2020. And that was extraordinary. 2 days, we had 40 speakers, 300 attendees from all over the world. And to see the passion for a community that they saw as nascent, that they wanted to be a part of, was something truly remarkable. But the main feedback from the community was that performance is something that we hadn't really prioritized up until then. It was very much focused on getting the language right, getting the software to at the right state, and not prioritizing performance just yet. So as 2020 started, we focused solely really on performance. The end result of that is that at the end of 2020, we rewrote the entire software. Not just rewrote it, we re-architected it. So under the hood, we used to depend on Cassandra and Janus Graph, and we decided to replace our persistent engine with RocksDB, and then we wrote our own graph engine, literally with the traversal engine and all of that, on top of which TypeDB is built upon. And now, I mean, short story, until now, we're actually more gearing up for TypeDB 3.0, which one of the major components of that is to rewrite TypeDB into Rust, which we're really excited about. We think that's going to give us a lot more performance. Also coming out with a managed cloud service for TypeDB. And I think a major point for us is that because we don't follow any semantic web standards, we're not a property graph, and I can speak more on that in a bit. We're really sort of defining our own category in the market. And that's both an opportunity and a challenge. Challenge because you have to educate, and education takes time. You have to be patient. You have to find champions that want to go on a journey with you. And that's something that we've really focused on a lot. For us is really the quality of the relationships that we have with the organizations. And simply because we don't fit within any of the existing categories of database software. And that's that's the major reason actually why we rebranded from Kraken to TypeDB. There's a lot to say there, but roughly that's sort of where we're at right now.
Sure. And your data model is very unique. That's one of the things I like about it, but it does draw upon other past research, past data models, that relational I mentioned. How much influence was there by other hypergraph databases at the time, back 2016, 2017?
I mean, so I think at the time, the only project out there was Hypergraph DB by Boris. We've worked with Boris.
Researchy things before that, but yeah.
And we've worked with Boris. We know Boris still actually quite really good terms. We have tremendous respect for the work that he does. For us, one of the guiding principles of the software in general is to take a lot of the science that is existing in the field, which goes back decades, really, from all the way back from expert systems, including hypergraph theory, of course, and make a database software that someone unfamiliar with them can actually work with. So our tradition is very, very much rooted in knowledge engineering, hypergraph theory, type systems, set theory, all of that coming together to build a software that, we've really done our best to try and build a language and a product that someone without a background in those fields can use it to build software that works with highly complex data without needing to understand all the semantic web standards, without needing to understand really what hypergraph is in the first place, or even what symbolic AI means. And that's been one of the major, goals that we've set ourselves for our lives in building this company, building this community, building this software, is that how can you create something that is so simple to use, but hides so much of the complexity behind the scenes. And, in that sense, we very much look up to Apple significantly, how they brought out the Macintosh back in the 70s, which basically made you unable to choose your GPU, your CPU, your motherboard, which a lot of hobbyists wanted, of course, to configure. But by denying you that freedom to choose some of those components, your mother effectively could, or your grandmother could use a computer instead of just a small section of society. And that's sort of also how we see a lot of the technologies that exist that we depend on. A lot of the math and a lot of the history is very, very long, and we literally build on the shoulders of giants, of course.
Yeah, and that's no small feat to make kind of graph databases approachable for developers, particularly when you put things like a type system into the mix, when you've got rules that are based on horn clauses, from what I understand. But one of the things I'm getting at is that maybe the learning curve is lower because developers are familiar with SQL already. They're familiar with the relational model to some extent. What is the actual interaction between TypeDB and SQL? Can you say issue SQL queries over a TypeDB database?
No. So there's absolutely no interoperability, at least not natively, between SQL and TypeDB. If we're being technically accurate, SQL as a query language and relational theory as something separate, we would be considered to be an abstraction layer over relational theory or relational databases. So
just not SQL.
Exactly, yes. So when you're,
sorry, I keep interrupting that, but you do consider yourself to use a relational model with
no, sorry, that's not what I meant. So so if you consider the relational model based on Cott's theory going way back to the 70s, representing data at the logical level, we would consider representing data in TypeDB at the conceptual level. So modeling things with entities, relations, attributes natively without having then to, let's say, normalize our data, impose some sort of tabular structure, or a relational structure. In this case, I mean relations as the definition as a relation of being a table in the mathematical. And for us, we would consider TypeDB therefore to be an abstraction layer, conceptually over relational theory, over a relational database.
Sure. So let's maybe talk about the data model briefly. So if you could give kind of a 1-minute overview, what are entities and relations and attributes and so on.
Yeah. So the model in TypeDB, we directly effectively implement the model as written, the entity relationship model as defined back in the 70s, I believe, by Chen in the 75 paper, where entities, relations, and attributes are the first-class citizens in the TypeDB data model. An entity typically is something that exists on its own, independent of any context. Let's say a car. A relation is something that has to exist in the context of other things. So that could be an event or a marriage. An attribute is something that belongs, like a property of a particular thing, and I define thing here because in our model, entities, relations, and attributes are all things. And therefore, by that extension, an attribute can be owned not just by an entity, not just by a relation, but even by an attribute. That's a little bit more of an advanced use case, but that's why when we say thing, we really refer to those three concepts. Then, as you pointed out in the introduction, we also have the concept of roles. And roles allows us to contextualize how a thing relates to the context of in a relation. The role could be, if you don't want to be too semantically accurate, could be the same name as the thing that plays the role in the relation. So you could have a person playing the role of person in a marriage relation, but maybe you want to be more semantically accurate and you may want to say that the person plays the role of spouse in a relation.
Sure. So from what I've understood, relations roles rather are kind of like, simple binary edges outgoing from an entity, or properties. By analogy with the property graph model. What's the difference between ownership and a role?
Let me briefly clarify one thing you said there. So a relation in the TypeDB sense is, and maybe I misheard there, is not a binary connection between two things or a pair of things. A relation in TypeDB.
Yeah, so I was saying a role is binary. It connects.
Oh, right. So a role, as opposed to an attribute, lives in the context of a particular relation. So something needs to have a role to be in a relation. And an attribute is simply the age that someone may have. So the ownership here really refers to effectively a literal that is owned by a particular concept to which it belongs to. Now, something important to know about TypeDB that is fundamentally different to other databases is that the concept of the attribute of type name, for example, that may have the value Andrew, that attribute, even though let's say there may be 1 million instances of people with that name, the instance of that attribute will only exist once in the database. So if you insert multiple Andrews, the database will deduplicate those attributes, and all those instances of those persons that have the name Andrew will point to the same instance of the attribute type.
Makes sense. I think there's an analogy, between um, uh, entities, relationships, roles, attributes to property graph, vertices, edges, properties, and property values, which may be helpful to this audience. But why don't we talk about the differences between the two, because that's really kind of what's fascinating about TypeDB, that you can have entry relationships. I think you just illustrated one there. Can you say more about TypeDB support for multi-way relationships?
Of course. And I mean, firstly, to think of TypeDB literally is an abstraction layer over a graph. The graph engine that we built, that effectively also, that is based on a graph model. The differences primarily is that TypeDB supports type inheritance. So for any type can be subtyped, so entities, relations, and even attributes, specifically through single type inheritance. The second is that relations are indeed n-ary, so that's where the concept of a hyperrelation comes in. So a relation in the TypeDB is a non-directional hyperrelation, and that directionality is important because the roles could determine the direction if you so wish, but if you don't, then there's no directionality. You could have roles that say start and from or to, then you can semantically represent the directionality, but not natively. It's not enforced by the database. Another important feature is that relations are truly considered first-class citizens in the model, and so that means that a relation can even refer to another relation. So you could have a marriage relation between two people, and let's say you want to localize that marriage. The marriage is a relation, and now I want to have let's say call it a localization relation that refers to the marriage and connects the marriage to a city. And so you've got a city that's an entity which refers to the marriage relation through another relation. And the ability to have those nested relations, that's quite a unique feature of TypeDB. Traditionally, if you're coming from a graph world, you would normally reify your data in those cases where instead of creating an edge, you would create a node. That's a common ways. And of course, there's ways around doing the type hierarchies. You could add, let's say, inside for multiple labels to a particular node. That adds complications in terms of safety. And so there's, of course, ways around it. But the native ability to do those things, that's quite unique to TypeDB. And of course, there's more things, but those are some of the headline things. And of course, also there's schema constraints. So there's safety on both read and write. Right, in terms of you have to define your schema up front. So you cannot write any data that doesn't adhere to the schema that you've defined. Extended the schema is very easy, by the way. You just write a line of code, open a schema transaction, and that's it. And similarly, when you're reading data, if your query that is fetching for data doesn't adhere to the schema, you're also going to get an exception. The idea being that if you're querying for a lot of complex data, it's quite useful to know whether your query is actually correct or not. Other databases may return an empty set if your query, even if your query is incorrect, because there's no schema to check the safety of the query.
Sure. Yeah, let's talk more about schema in a moment. What is the unique identifier of a relation in the graph? Is it just the combination of all of the roles in the relationship? Sort of like you said, an attribute is, you may find occurrences of an attribute in many places, but there's essentially only one logical attribute. Does that apply to relations as well? If they have all,
say that
the same relationship, or do they have a unique ID?
I mean, of course, you could create an attribute that's a key. Then of course you could define that as part of the schema to identify uniqueness. Other than that, there is a concept of an internal identifier that TypeDB uses to identify instances of concepts. But typically, we don't recommend to use IIDs, which is the shorthand for internal IDs. And we would recommend to create your own attribute to label certain things and make that attribute a key, for example, to denote uniqueness.
Yeah, just kind of comparing and contrasting again with property graphs, where you typically do vertex or an edge have an ID, and an element, two elements with the same data are distinct if they have different IDs. Let's talk more about types, because that's one of the things that really makes TypeDB powerful enough that you put it in the name. So it helps you write better queries. What else?
Well, the fundamental purpose of having a type system is that you can maintain consistency in your data. And we see this a lot because obviously the graph space has matured quite significantly in the last couple of years. You see this in the amount of funding that has gone into some of our good friends in the space. But what's interesting is that we see quite a lot of actually high-profile organizations that are coming to us because let's say they've been using one of the big vendors for 2-3 years for production system, but the data begins to get unwieldy. And there's no real easy way to maintain consistency of the data. And ultimately it becomes a mess. So you're either forced to do a lot of work to get safety, or you have no safety in your data. And so the modeling side of maintaining that consistency of data and also doing it in a way that's simple and easy and readable, those are some of the key reasons why we see people switching to or coming to us for TypeDB. I wouldn't say it's something. So on face value, and we sometimes do get that feedback. It's, let's say, easier to start with a traditional property graph because you can just start push data in. Don't worry about the schema; it doesn't really matter. Just start pushing data in. And with TypeDB, there's that extra step of I have to define my schema in the first place before I can start to ingest data. Down the line, and especially for the use cases that TypeDB is used for, that can become a problem because we want to maintain we want to create a data model that is consistent, that is easy to read, this is maintainable, and is enforced at the database level. Yeah.
Sure. I can definitely appreciate that. I've seen many different companies and projects building knowledge graphs on top of the labeled variant of the labeled property graph data model. And obviously, I'm a fan of property graphs, going way back. But you do run into problems, particularly when you start trying to combine different data sources into the same graph, which is something that you have to do constantly with, say, an enterprise knowledge graph. So I can definitely appreciate how having a strong schema, how that emphasis on schema helps. How do you typically bridge the gaps between schemas as you're building, say, an enterprise knowledge graph? You have, like, to make it concrete, suppose we have 2 different TypeDB databases with each with their own schemas. We want to bring them together and build a super knowledge graph, a combined knowledge graph out of the 2. What is your approach for kind of reconciling or merging the schemas so that you can do that effectively?
I mean, ultimately, it's down to where we usually come in, and this would be not just for TypeDB schemas, but let's say there's a SQL database you're trying to incorporate in as well. We like to be as this is our advice, is to be as practical as possible. If you're in an organization, what's the business use case? What are the questions you're trying to answer? And sort of work backwards. What's the model that needs to buttress those questions that need to be answered? And that informs a lot of what the model should look like. And of course, check what's the data that you have available. But the most important thing is to go through that exercise of data modeling, or more accurately, the process of knowledge engineering, because that's where you create the intellectual property for that particular organization, especially if you're in industries such as pharma. Integrating those databases becomes integral. The model that you create there becomes integral to the value of that software and the enterprise value that gets created from those applications. So I start with the questions because we have seen instances where there's just so much emphasis on getting the model right, and in so many of these domains, you can spend such a long time debating what's the right model, and ultimately lose track of what's the real business use case, especially if you're in a commercial organization. Maybe if you're maybe in a research organization, is different. But if there are business outcomes that need to be taken into account, having a really strong focus on getting the outcomes front in mind is essential to getting the right stakeholders to keep funding, keep supporting, to make sure that the project continues, of course, down the line.
Yeah, so essentially defining the questions that you want to be able to answer based on the knowledge graph. What about adapters? You mentioned SQL, and we've already said that TypeDB is not SQL based. It doesn't have any built-in support for SQL. But I imagine the mapping from relational databases into TypeDB is relatively straightforward. How does that work?
It's a good question, and we get it asked all the time. The last couple of years, always this question comes up. It's a very, very valid question. Our standard answer is really that you could create a generic mapping, and actually we used to have a generic migrator from SQL into TypeDB, which is, let's say, a table is an entity, a foreign key, maybe a relation, and columns are attributes, and that can work technically speaking. But usually, I would ask the question: if you're doing that, why would you switch to TypeDB? I mean, firstly, TypeDB as a software is of course less mature than something like Postgres. And Postgres is an amazing piece of software. So if you're not going to benefit from the additional modeling capabilities that TypeDB offers you, and let's say if you're not really going to use the reasoner either, why would you make the effort to make that migration? So we always try and show that a lot of the benefit of using TypeDB is to rethink the model, because obviously the world doesn't work in rows and tables, rows and columns, and so, but we're so used to thinking to enforce a tabular structure on our data that we just think in terms of table. That's how the world has worked has worked very well, of course. But for so many use cases, we should want to think more conceptually. And that requires you, of course, to be familiar with the TypeDB data model and have some comfort on what the art of the possible is. Basically, my answer is that you'd want to rethink your model a little bit, and that if the way we modeled it in Postgres or in an SQL database probably is not going to be the same way how you're going to model it in TypeDB.
Yeah, fair enough. And TypeDB is a lot more expressive than most of the languages out there for relational storage, or for streaming and microservices and so on. But one of the common reasons you would ETL foreign data into a database is that you want to combine it with other data, as kind of I alluded to earlier. So even though you might be starting out with a data model that isn't taking advantage of all of the facilities of TypeDB, often that'll be useful in building an enterprise knowledge graph. To take another example, maybe you have data streams or events that are being sent over Kafka using an Avro schema or something. So you'd want to map Avro into TypeDB, or maybe you have a microservice that is gRPC based and using a protobuf. So I can see a lot of opportunity, and imagine that some of your customers are dealing with these issues of mapping X into TypeDB, where X is some other schema framework.
Yes, of course. Ultimately, it really depends. We see a variety of use cases naturally. The major thing is, and that's the responsibility that we put to ourselves, is to get someone up to speed where they can tell us on what's the best way on how to do that. So that's the role, especially when you're doing category creation in the market, is you cannot tell people exactly how they should use your software. You can give pointers, but you always want to make sure that there's enough room for someone else to create serendipity, and that can be in the way how different data streams connect to TypeDB, or how metadata is being modeled, and that's the beauty, I think, of being also open source, because a lot of those examples may be developed in an open source way, and then maybe a commercial customer comes out and they start implementing that, and that happens quite often. And across the industry, I would assume. So, and as a side note, by the way, our client server communication protocol is based on gRPC and protobuf, as a side note.
Well, maybe one more question about the type system before maybe we move on to applications and how TypeDB is being used in the wild. Inheritance is not something I've thought a lot about in terms of the type systems that I've dealt with. Where do you see type inheritance being used, and where is it really providing the most value?
Again, in those data sets that are complex, which is sort of a very broad statement to make, but by complexity I really mean domains where there's a lot of different types of things. And so you may have a domain, let's say in the biology, where there isn't just one type of protein, but there's a lot of types of proteins. And let's say there's different types of interactions. So let's say you want to know for how do a specific subtype of protein interact with a compound. So you could write that query, but maybe there's, like I said, there's also different types of interactions where, let's say, a compound binds to a protein or a compound inhibits something, or other molecular types of interactions. And so you may want to be very specific in how you're expressing that question. And so you want to define the type of interaction accordingly. But equally, you may also want to get all the types of interactions. And the ease of using type hierarchy simply means that your, queries that otherwise would be very complex, you can reduce to just a few lines of code. And that's where the perceived magic, let's say, lies in TypeDB. We have some of these screenshots where we've been able to reduce 150 lines of code of SQL into just 3 lines of code in TypeQL. And yes, it looks, we're not trying to bash SQL. We have so much respect to the work that has gone before us. But it sort of makes the point that if you are making these types of queries, and using type inheritance is something that can really, really save you a lot of time and effort. So effectively, where there are a lot of different types of things, and you're trying to query across them, because not just will it save you from, let's say there's 10 different types of vehicles, and you want to query for all of the types of vehicles, not just can you just query for one super type, but if you want to look at the combination between those 10 types of vehicles that are connected to 3 other types of things, you're effectively otherwise having to write what would be quite quickly a combinatorial explosion, all the different types of traversals that we have to write. So that's where type inheritance becomes very, very useful on the querying side. And of course, on the modeling side, it sort of makes sense sometimes to create these subtypes, some that, for example, have only these types of attributes or these types of roles, but their parent can have these other roles. So there's benefits sort of throughout.
Is there any relationship between extensible types in TypeDB and GraphQLs? Are they kind of analogous, or are there any major differences? So if I were coming at TypeDB from a GraphQL background, would inheritance in TypeDB seem familiar to me? Yeah. Or is it a different beast?
I'll be very honest, I'm not too familiar with GraphQL from an application standpoint. We have a lot of users using GraphQL. So I wouldn't really be able to comment that in a comfortable way. The main thing is that GraphQL as an API maps well to TypeQL, but ultimately it's still using binary relations. So if you're defining your GraphQL schema, there's still a little bit of sort of tinkering of how best to do it. But on the inheritance, I'm not too familiar, so I don't think I can comment on that.
Right. Okay. Well, as far as query languages go, I wanted to ask you. I understand that queries or rules in TypeDB are Prolog based or inspired by Prolog. Can you say a little bit about inference?
Yeah, I mean, more specifically, Datalog has been a big inspiration for the reasoning. I mean, in practice, what I think most people would benefit to know is that the rules are actually really powerful. And I'll be honest with you, it's the most challenging aspect of communicating that to the world. because there's so much math behind it. If you're in automated reasoning, you sort of, you know what reasoning can do for you. But for a lot of people that are not familiar with the space, and people that equate inference with machine learning inference, you know, there's a lot of work that we still need to do in the world to educate, and the space in general, why automated reasoning is so powerful and works really well with machine learning. And sometimes we think we are at fault there, because the rules are sometimes considered to be so simple, because you just define a set of conditions, and if those are true, then you infer a new fact, like a horn clause. But again, to appreciate what that can do in practice, that's something that we're, you know, very keen to do more sort of education around, because the ability to create rules that infer a concept, and if that concept can be used in another rule that can infer another concept, the ability to chain rules, the ability for rules to work together in that sense at query runtime with performance that is equal as if the data is persisted. All of that is something that, you know, that's how we build the database. That's how we want people to use it in a transactional way. And lastly, a feature that we will be adding is the ability to do arithmetic in rules. So the ability to do n+1 in the conclusion of a rule, for example. So the inference is definitely, I think, the automated reasoning in general is still a huge, I think, growth area for people to learn how they can leverage that for their use cases.
Yeah, I'm definitely sold on data log and graphs. I had Scott Meyer, who's the creator of Liquid here at LinkedIn, on the Graph Show a few episodes ago. Also, there was, I was always kind of fascinated by the datomic database, even though it's not, a graph database proper. But I'm curious how you arrived, and there's been work on reducing Sparkle query evaluation to a data log and so on. So lots of kind of connections to the graph space. But how did you arrive at a data log as a solution for rules and TypeDB?
So personally, I wasn't the one to write the initial draft of the reasoner. That primarily was someone called Casper, and with Heikel, already 5-6 years ago. So I don't think I can say too much on that. The main thing for us is that the ability to create something that can be used for people that doesn't require them to know logic as a background. That was a huge motivator. A lot of the stuff that we study. So my partner Heikel, he did automated reasoning and knowledge representation at university purely because he loved the math, not because he actually thought he could use it to build anything in the future. And it was only when he got introduced to some really large schemas in supply chain primarily that he thought actually some of that math could be used to build the new type of database, that we sort of arrived to making this type of intelligence, this type of ability available for a CS undergrad that just graduated. And so if you're building a startup, if you're building a company, that you have these computational, this type of logic available for you without needing to again hire PhDs in logic. Not that I mean we hire PhDs in logic of course, but when you're building software, to have something that is simple, expressive, and massively expressive at the same time.
Sure. Well, we're almost out of time. I thought we could talk just a little bit about, TypeDB in the wild. How's it being used? Tell us about a few of the knowledge graph projects that are out there.
So in general, we've seen a lot of adoption in the life sciences. So pharmaceutical drug discovery on the molecular side, as well as the diagnostics side. You can imagine there's a lot of type of data, and not just complexity on the biomedical side, but particularly all the data that has to be integrated, right? We spoke about that earlier as well. Different specifications, different data standards. So we've seen some really cool stuff on the drug discovery where you can, let's say, integrate a bunch of publicly available data sources, protein data, drug data, combine that with lab data, so assay data that comes in, and then use machine learning to make certain predictions, push that into the database as evidence to then, for example, try and predict 20 gene targets that may be of more interest. And not just that, but also get some sort of explanation what is the evidence that supports these gene targets to be more valuable. And the machine learning works great here because it provides evidence to those predictions. In biology, particularly, machine learning is notorious because it provides very little explanation why a particular target is useful. And that's why automated reasoning becomes so interesting, because if you know that this target may be interesting because it's located near on the chromosome of another gene that is known to be associated with that disease, I'm making sort of this up, but that logic becomes very valuable to hypothesize in biology. Then we also see a lot in the security space lately. So in the defense and cybersecurity, again, representing data from a lot of different sources. There is an open source repository we have available in the cyber threat intelligence space that integrates a very interesting CTI specification in TypeDB, which is the full schema is like 1,700 lines of code. I think it's massive, but it's a very interesting specification that was implemented in TypeDB. And then there's a long chain of other use cases, from space mission design by the European Space Agency to supply chain management with IBM to of course, fintech, e-commerce, anything really that works with complex data. There's this really cool startup. I'll give them a shout out, Loic at Blitz. They're building an Airtable equivalent or Airtable competitor. And so you can imagine, if you're building an Airtable, you're building a software that allows you to create schemas. So what database are you going to use that allows you to give people that level of expressivity? So it's a fascinating piece of work that they're building. Check them out. They're called Blitz. And so the fascinating use cases. And I guess even with here in London with the Natural History Museum, we're starting to start a partnership with them where they're trying to model the complexity of of nature. And some of these things you don't anticipate, of course, before you start something like this, because for us this isn't just a job, this is our lives, and we feel this is some of the best work that we'll ever do in our entire lives, and the impact you can have on those use cases is tremendous. And it makes it easier to explain to your family and your mother, which you do as well. You can see that passion in your videos and elsewhere. You mentioned a reusable schema. I think you have more of those, right? Sort of standardized models that can be picked up and used. So we have an OSI organization called TypeDB-OSI. So if you go to github.com/TypeDB-OSI, there's a bunch of repos there. There's one for biology. There's one for cyber threat intelligence. The Pandora papers is there as well. There's a robotic schema that we're going to push on there. We haven't created that one, but the schema is ready. So there's been a lot of work on robotics actually as well with TypeDB. And actually the Boston robotics spot robot, one of the National Dutch Institute of Research uses TypeDB to navigate, uses TypeDB to create an environmental model and a task planning module on that robot, which is really, really cool. And there's a bunch of others that I may be forgetting, but that's the repo, that's the organization to check out for examples. Sure, thanks. Well, I have to go. Work is calling, but it's been a really interesting conversation, Tomás. I appreciate you taking the time. Any closing thoughts? I mean, thank you, Josh. I really appreciate the time here. Like I said, for us, the challenge is great because we're doing something quite different to what everyone else is doing in the space. And if anyone is interested in coming on a journey with us, reach out to us. We're open source. We've got a community on Discord and forum, and anyone's welcome to ping me with ideas, or even if things they disagree with our approach. We're always happy to have a dialogue. Awesome. Looking forward to following your progress. Thanks again, Tomás. Thank you so much, Josh. The Graph Show. I'm Josh Shinavier. This has been Tomás Sabat.
Thanks again.